All right, so we come to this problem in 2.6, question 13. 2.6, question 13. Find the x and y intercept of the graph of the following equation. This is the equation given to you. This equation given to us, we can also call this our y. Okay. Also test for symmetry about the x-axis, y-axis, the origin, and the line y equals to x. They may not state these four explicitly. Okay, sometimes the question may say, also test for symmetry and full stop. So you are expected to test for the symmetry about x-axis, y-axis, the origin, and the line y equals to x. So please take note of that. Now, to do this, so the first thing is that we are testing for the y-intercept and x-intercept, or x-intercept and y-intercept. Okay, so label your working properly. First, testing for x-intercept. Okay, when we're testing for x-intercept, what do? We equate y to 0. That means we equate y to 0. So if you equate y to 0 here, we are going to be getting 0 equals to x raised to power 3 minus 2x plus x squared all over s squared plus 1. All over s squared plus 1. S squared plus 1. Okay, so we cross multiply. When you cross multiply, we have x minus 2s squared plus x equals to 0. Okay, now you factorize x out here. You got s2 minus 2x plus 1 equals to 0. So what we have here is that x equals to 0, or s squared minus 2x plus 1 equals to 0. Okay, so we factorize this. This is a quadratic equation. You can use the quadratic formula, or you factorize it. So we have s squared minus 2x minus x minus x. Okay, that's fine. Minus x plus 1 equals to 0. So we have x into x minus 1, and then we have minus 1 into x minus 1 equals to 0. Okay. Then we are going to be having x minus 1, another x minus 1 equals to 0. Okay, so we have x minus 1 two times, so x equals to 1. Okay, x equals to 1 two times. Okay, so we have the x-intercept will be at 0 and at x equals to 1. That is the x-intercept. So our x-intercept is at x equals to 0 and 1. That is our x-intercept. Okay. Now let's go to y-intercept. Y-intercept. The second one is y-intercept. That means we equate x to 0. Okay, in the formula, or in what we have, if we equate x to 0, y will be equals to 0, 3 minus 2, 0, plus 0, all over 0 plus 1. Am I right? Okay, let's check. Yeah, 0 plus 1. So we're going to be having there 0 over 1. So that means the y-intercept is at 0. Okay, y-intercept is at 0. Okay. Now the next thing is to now go into our symmetries. Okay, the first one, we want to find the s-axis. Okay, symmetry about the s-axis. What do we do when we are finding symmetry about the s-axis? We replace every y with a negative y. We replace every y with a negative y. Okay, that means I'm going to be having negative y equals to s3 minus 2s squared plus x over s squared plus 1. Okay, then I rewrite this. I will have y equals to, I multiply both sides by negative, and that will become okay, that negative, you can either multiply it by the numerator or by the denominator. Okay, you don't multiply the negative here and the same here. No, that will be wrong. So you multiply it in one of the, either at the denominator or at the numerator. Okay, so we can see this is what we get, and that is different, totally different from what we are given. So there's no symmetry, and you must conclude no symmetry about the x-axis. Please make sure you always conclude no symmetry about the x-axis. Okay. The fourth one, we are finding symmetry about y-axis. Symmetry about y-axis. Please, when you are working, you must make sure that you comment properly on what you are doing. Don't lump up your calculations. Ensure that you comment properly about what you are doing. In this case, we replace every x with a negative x. Okay, we replace every x with a negative x. So we are going to be having y equals to negative x raised to power 3 minus 2 negative x raised to power 2 minus negative x all over negative x raised to power 2 plus 1. Okay, let's try to simplify that and see if we are going to get our original equation. This one gives us negative s3 because of negative 1 raised to power odd number give us negative 1. But negative 1 raised to power an even number, either 2 or 4 or 10, will give us positive 1. Okay, so this one gives us negative x raised to power 3. This one gives us negative 2s squared. This one remains negative. All over this one gives us positive plus 1. Okay, if you look at this equation, with the original equation that we have, this is the original equation. Let me write the original equation again here. Original equation. Okay, this is the original equation. If you compare this with the original equation, you will discover that they are not the same. So there is no symmetry about the y-axis. Okay, so the next thing is we want to find symmetry about the origin. This is 5. Symmetry about the origin. Symmetry about the origin. Okay, in symmetry about the origin, we replace every x with a negative x. We replace y with negative y. Okay, so let's replace them in our original equation, which is this. We replace x and y with negative. We replace x and y with negative. Let's use this one. We replace x and y with negative. We are going to have negative y equals negative x raised to power 3 minus 2 negative x raised to power 2 negative x over negative x squared plus 1. Okay. So let's try to simplify and see if it will give us the same equation. Negative y becomes negative x3 minus 2x squared minus x all over positive square plus 1. Okay, let's multiply through by negative y. If you multiply by negative y, then we are going to have negative 1 rather. Then we are going to have this. The negative will come up. S3 minus 2s squared minus x all over s squared plus 1. And that will give us positive this also, positive this, all over s squared plus 1, which is equals to y. Okay, if we compare this with what we have, we see there's a negative on 2s squared. But here, everything is fine apart from this one. So, no symmetry also. Please take note and make sure you conclude. No symmetry about the origin. No symmetry about the origin. All right, so the last symmetry we need to test now is to test for symmetry, that is 6. Symmetry about the line y equals to x. Symmetry about the line y equals to x. To test for that, we replace every x with y and every y with x. Every x with y and every y with x. So I will have, instead of y here, that will be x. Instead of x, that will be y minus 2y squared plus y all over y squared plus 1. Okay, so when we replace every x with y and every y with x, then we make y the subject. Don't forget, when we have this equation, y was the subject. Here, that is the original one. That is the original one. Okay, so we try to make y the subject in order to see if there's actually symmetry. Okay, and if you cannot make y the subject, it shows that there's no symmetry. Okay, about the line y equals to x. So if I cross multiply this, I will have x into d squared plus 1 equals y3 minus 2y squared plus this. Okay, I'm trying to make y the subject. Okay, so you will see now that if I factorize y out here, I'm going to be having y squared minus 2y plus 1. Okay, so let me just make 1y. So if I make 1y, that will become x y squared plus 1 all over y squared minus 2y plus 1. Okay, you see when I make y the subject here, there's still y on the left, on the right-hand side. So we cannot make y explicitly y explicitly the subject, just like we have in the original equation. So because of that, there is no symmetry. No symmetry at the line x equals. So no symmetry at the line y equals to x. No symmetry at the line y equals to x. Okay, please ensure that you understand.